Okay, this is where now it starts to become fun, because now we're going to look at a generator producing a voltage given by the following formula. Looks to me like the maximum voltage of that generator is going to be 200 volts. Although I should have said to you, it says time t is in seconds, but it doesn't say what the y-axis is. So I'm going to assume that the voltage is in volts versus, kilovolts, of course, or millivolts or whatever. Sketch one cycle of the curve and verify your results using the graphing calculator. The amplitude of this curve is the 200 that's in front of the cosine. The period is found by taking 2 pi divided by b. I'm just going to keep reaffirming that. B is everything that's in front of the variable, and the variable on the x-axis, where t is the time in seconds, is what we're going to graph on the x-axis. So what's in front of the variable t is 50 pi. So I find it kind of nice to cancel those out, and then I like to think of this as 1 over 25, which I happen to know, of course type it on your calculator, is 0.04. So that means one cycle takes 4/100ths of a second. 4/100ths of a second to complete. And it says, sketch one cycle of this curve. I'm going to be a little particular here and try to draw some straight lines. Hopefully that's going to work. Dang it. All right, and let's see, it's a cosine curve, and it starts at 200. So I'm going to come right here and put a mark for the 200, and maybe I'll put a mark down here for a negative 200. And again, a cosine curve, so there's a quarter, here's a half of the way, here's 3/4 of the way, here's one cycle, because at this point I would start the cycle over again, just like prior. So I'm going to go ahead here and put the 0.04, because the x-axis represents the time that this is running, and time is represented in seconds. So please, you have to label your x-axis, and you have to tell me that what it's called and what the units are. Over here, I need you to call this y-axis and tell the reader that this represents the voltage, and that the units for that are in volts versus kilovolts or millivolts or whatever. From here, I would like that you go ahead and put half of the 0.04 right here. So it looks like every quarter here is 1/100th of a second, then 2/100ths, then 3/100ths, and then 4/100ths. So if you would hit your y equals key on your graphing calculator, if you would type in y equals 200 times the cosine of, I think it'll open parentheses, 50 pi x in close parentheses. Then would you hit the window key, and would you put for an x min, would you put 0? Because we started this curve at a time of 0. And for an x max, would you put in 0.04 seconds? For the scale, I might put in, I think it would say scale there for you, so x scale, I would probably put in 0.01. Not that that's real important, but these occurred in increments of 0.01, 1/100th, so that would be kind of nice. The y minimum is a negative 200, but what do you say you put in a negative 250? And the y maximum is a positive 250. And maybe for a y scale, you can put in 50 unit increments. So it would go 50, 100, 150, 200, and it'd go up here to 250. So you could put that in for your y scale. And just check it. And then once you're done, would you hit the trace key and then right arrow? So then hit the right arrow key. It looks like this. And move along and see that you see this 200 high point. See that you can see that 0.01, the 0.02 at the bottom for x, the 0.03. See if you can see this maxing out when time is 0.04. Because look, the next question says graph the same function as above, but this time graph the function for a domain between 0 and 0.06 seconds. So what do you say we just go ahead and continue this curve up above? If I want to go not just to 0.04, but I want to go out here to 0.06, wouldn't I just go, here is 0.05 and here is 0.06. I'm going to go ahead and erase that so we can see it. And I see that what I need is 1.5 cycles of this curve to take this out to 0.06 seconds. So this is just the domain, and for whatever reason I want you to just go out to 0.06 seconds. This one's pretty easy because the increment's 0.01, 0.02, 0.03, 0.04. Let's see what this next one says. Oh, it says sketch one cycle, but you are going to be asked to do some problems, some stories, where I tell you the domain to graph the function, like we did in this last one. So here's the velocity of a piston in an engine. You know, piston, probably this is bad, you know, and it's going to go down and up and down and up and down and up. And its amplitude, it's going to reach a height of 5, and this affects the cycle, the time it takes for one cycle. So let's go ahead and let's state that the amplitude is 5.0 and that the period is 2 pi divided by 1,600 pi. Oh man. But the pi's will cancel out at least. And then what I would do if I were you is 2 over 1,600 is 1 over 800. And as a decimal number, I take my calculator and find out the decimal number. That's 0.00125. So if you wanted to graph this on your graphing calculator right now, your window, and I would consider doing this, please. Your x max starts at 0, and I'm sorry, your min starts at 0, x minimum. Trying to erase here, it doesn't want to erase. I'm going to go ahead and do this, minimum. And then x max goes, for one cycle, is 0.00125. You could just put that, really. And then don't worry about the scale because it's too hard to decide what to put here for increments. And then my y minimum would be a -5, and my y maximum would be a +5. Go ahead and do that just so you can see this curve. But now I'm going to sketch one cycle of this curve by hand. And I just wish to be sure. So what do we have? A cosine curve that starts at 5.0. So let's, and I'd like to kind of make it tall and skinny because it all happens so fast. You could put right here 0.00125. You absolutely could do that. But please remember that it's also 1 over 800. And so if you wanted to get, yes, you could take half of that number and put the decimal number here, but half of that would be 1 over 1600 for right here. And half of that right there would be 1 over 3200. I'm not sure I really should advocate for that. That's getting a little bit messy. So the 1 divided by 3200 is 0.0003125. Still too hard for me to write. This 1 divided by 1600 is 0.000625. And then if I take this 0.00125 and multiply it by 3/4, then this quarter point, which is supposed to be a quarter point, that spot right there is 0.0009375. Again, please label the axes. So V is the y-axis is the velocity. So this axis should say velocity for the y-axis, and you need to tell me it's in centimeters per second. That's how that piston is moving. And then t is time on the x-axis, and the units are in seconds. We'll do more, especially of the applications in class. So work away at this and bring your questions to me, and we'll kind of wrap it up, if you will.